Hi everyone, this is your math guru. In this video, I'm going to show you how to solve the following problem using the trig ratio and your sine rule. In the diagram below, A and B are two hot air balloons. The angle of elevation of balloon A from C is 20 degrees and the angle of elevation of balloon B from D is 25 degrees. Points C and D are 2 kilometers apart. Determine how many meters high balloon B is than balloon A with respect to the ground. To start with, I need to calculate the height of balloon B from the ground. Likewise, the height of balloon A from the ground. After calculating, I'll subtract the height to know what the difference in height is. Because I've drawn the height perpendicular to the ground, this is angle 90, and likewise, this is angle 90. I'm going to tag this point E and this point F. So to find the distance BE, I need to find the height CB to complete the right angle triangle. And I can do that by using the triangle I'm highlighting as shown. Note that to find the missing angle here, angle on a straight line add up to 180. So I have 180 degrees minus angles 80 degrees plus 20. And the reason being, that's a straight line. Therefore, the angle at C would be 180 minus 100, and that will give me 80 degrees. So this angle is 80 degrees. I'm going to do the same on this side to find this missing angle, because that's also angle on a straight line. I have 180 minus 25 degrees plus 75 degrees. That will be 180 minus 100 degrees, and that will also be 80 degrees. So this angle is 80. So using the triangle BCD, I'm going to draw a rough sketch here. I have my D, I have my B, now that's my C, I have C and B at the top. I have this angle, that's the total angle here as shown in the diagram. That's 80 plus 20, that will give us 100 degrees. I have the angle at D as shown, that's 25 degrees. Therefore, to find the angle at B, the sum of angles in the triangle, that's 180 degrees. So the angle at B will be 55 degrees. Therefore, applying the sine rule, I have the distance BC over the sine of the angle facing BC, that's 25 degrees, is equal to CD, has been given us 2 kilometers. That will be CD 2 over the sine of the angle facing CD, 55 degrees. If I cross multiply, BC will give me 2 times sine 25 degrees divided by sine 55 degrees. Therefore, my BC, or the distance BC, will be 1.032 kilometers to 3 decimal places. And because I know the distance BC to be 1.032, I can use the right angle triangle as shown. I'm going to draw a rough sketch here. This is my E, that's the right angle. I have C, I have the angle at C, 80. I already know the distance BC to be 1.032 kilometers. I can find the height of the balloon B using my trig ratio. the trig ratio to use, if I label all the side facing my angle is my opposite, the longest side is my hypotenuse, and the last side is my adjacent. Because I'm looking for my opposite, I already have my hypotenuse. I'm going to use sine. So I have sine of angle 80 degrees equals opposite over my hypotenuse, which is the same as BE, the height BE over hypotenuse is 1.032. Therefore, to find the height BE, I have that as 1.032 times sine 80 degrees. Therefore, the height of B, the balloon, will be 1.016 kilometers from the ground. I'm going to put that here, 1.016 kilometers. Now I need to repeat the same thing on my right hand side. This time around, I'm going to be using the triangle ACD in order to find the distance AD. The ultimate goal is I need to find the height of the balloon A. So, using the diagram shown, I'm going to draw a rough sketch. This way, I have balloon A, I have D, and I have C. The distance CD has been given as 2 kilometers. I have the angle here as 20, as shown. Then I have the total angle at D to be 80 plus 25. That will be 105 degrees. Sum of angles in the triangle, that's 180. So to find the angle at A, that will be 55 degrees. 180 minus 20 plus 105 degrees. Therefore, to find the distance AD, I'm going to use the sine rule. I have AD over the sine of the angle facing the side AD, that's sine 20 degrees, equals CD, that's 2 kilometers over the sine of the angle facing CD, 55 degrees. Therefore, to find AD, if I cross multiply, I have AD to be 2 times sine 20 degrees divided by sine 55 degrees. And if you punch this in on your calculator, you have it as 0.835 kilometers. Now that I know my distance AD to be 0.835, I can go back to my right angle triangle in order to find the height of the balloon A. I have this as point F as a right angle triangle. I have the angle here to be 75 degrees and the distance AD is 0.835 kilometers. Therefore, to find the height AF, I'm going to tag my triangle, the side facing my angle, that's my opposite. The longest side is my hypotenuse. The third side is my adjacent. To find AF, using my trig ratio of sine, I have sine angle 75 degrees equals opposite, that's AF, over hypotenuse 0.835. Therefore, the distance AF equals 0.835 times my sine 75 degrees. Therefore, AF is equal to 0.827 kilometers. So going back to the question, we have to determine how many meters higher the balloon B than balloon A with respect to the ground. So I have the distance of balloon B to be, I have BE minus the distance AF, and that will be 1.016 minus Remember, we're still working in kilometers. 0.807. That's the distance of balloon A. That will give us, if you subtract, 0.209 kilometers. But we're asked to find the distance in meters. So therefore, changing to meters, I have multiplying by 1,000. 1,000 meters make 1 kilometers. The distance will be 209 meters. That's the difference between the height of the balloon A and B. Thanks for watching. Bye.